So I'm going to start on the sheet that is not the college football one. And start writing on the other one. We are actually going back to chapter 3. We teach chapter 3 and chapter 12 together, which we usually typically do anyway, except one section. So today, basically, the beginning of this is algebra with two different variables, and the relationship between two different variables. So on this sheet, an explanatory variable may help explain or influence changes in the response variable. If something happened first, obviously that has to be your explanatory variable. Sometimes it's not always that something happened first, like our football example, but this one is very obvious of which one is the explanatory, which one is response. Sometimes we're doing stuff to see if there's a relationship, and sometimes it's not as obvious. But for the most part, for our class, unless we come up with an example on our own, we're going to be doing one that has a more obvious explanatory and response. So response is just measures the outcome of a study.
Can you repeat what you said?
Just saying that usually one's going to be more obvious than the other. Like, it's obvious which one's which for our class. Sometimes, like, we'll make up one example in class, and we'll have to decide which one we want. But as far as, like, a test, I'm not going to have one that, like, goes in which direction. Alright, so I'm going to be flipping back and forth, like, between these. So, like, we'll talk about generally what it is, and then I'm going to do it alongside this example as we go. So I didn't write population on this sheet, but I shouldn't have to retell you what population is. So on your sheet that if you're watching this, you should have printed out or looking at it on the computer. And it's different stuff. It says CFB 2015 statistics. It's college football 2015 statistics. I just took 3 different of the conferences. So the population here, what are the individuals? In general, one word, the teams. So we know that there's specifically what kind of teams. Football teams win 2015, and only ones that of these 3 conferences. So 2015, yeah. 2015 college football teams. SEC, ACC, and Big 12 conference. I just picked 3 of them. And now I can't remember, is there a Big 10 and a Big 12, or is Big 10, they used to be Big 12? Okay, there is both now. I can't remember which one. And some of the other, I was looking at it really quick. I think the Big 12 might have changed, because I think, isn't it the Big 12 actually is 10 or something?
The Big 12 has like 10 teams, and the Big 10 has like 12 teams.
Yeah. Okay. Yeah, they've redone it. It looks like all the SEC are the same. I think the ACC is the same. I think Maryland had just moved out. No, Pitt's not in there. Oh, Pitt is in there. But I just picked 3 of the conferences to include. So we've already talked about this as far as a class and on the video. We have points per game and yards per game. Which one is going to explain the change? Which one is a more obvious one that explains the change in the other one? So our explanatory variable here is going to be yards per game. If you have more yards, just set it somewhere, you're more likely to have more points. The more yards you get, should increase your points, but getting more points shouldn't make you have more yards. So my response variable is points per game. And the part that we did before the video is we went ahead and put these in our calculator, and it's easiest if you go ahead and put these in list 1 and these in list 2. You can do it opposite and then make changes in like your settings, but it's just easier to go ahead and put your explanatory in list 1 and your response in list 2. Alright, so should have done this before too. I'm going to talk about it so that I can split the video here. Let's go ahead and go straight through talking about things that can happen with the scatter plot. What do you think the graph of this scatter plot is going to look like? What do you think is going to happen with teams who have very little yards per game? As far as what we have on here. They're going to have less points per game. Teams that have more yards per game are probably going to have more points per game. So what does that look like on a scatter plot if low matches up with low and high matches up with high?
Skew.
So if a team doesn't have many yards or low yards, they have low points. So it's going to be positive linear, right? In general, we can get that idea, which we're going to actually show in a second, but I just want to be able to talk through that idea. That doesn't mean it's always going to be. Linear is not the only option, but as far as our class for now, it is going to be linear or nonlinear. Now, obviously, are those the only different types of relationships you can have? No. But at this point, for chapter 3, we're only going to be dealing with linear and nonlinear. When I move into the chapter 12 stuff, we'll bring in some other specifics. So we just talked about we could figure out that it was linear based on theoretically the what that I drew up here,
The relationship between
and like visually the what. What's that called? So visually from the scatter plot, we should be able to tell
which one's the scatter plot, the graph.
with the dot graph. Yeah. And then there's something else called a residuals plot, which we don't know what that is right now. You guys were more specific than just saying that it was linear. You said what about the direction? Positive. So direction, positive or negative. And so I'm going to write this one as generic and then go back. So ours was positive. It can be positive or negative. How could we have just gotten the idea that it was positive based off what we were talking through?
High values and high values.
And so if we had made it, it would have shown on our scatter plot. Now, there are a couple other things. We're either going to have a positive or negative R value, which we don't know what that is right now. And we're also going to have a positive or negative something else that you should know about from algebra. If it looks like this, our graph has a positive what? And so these two are always the same. As far as if one's positive, they're both positive. If one's negative, they're both negative.
But they're not either.
Now strength is just going to be, is it strong, moderate, or weak. So just for right now, I'll write strength is strong, moderate, or weak. It doesn't really matter about color right now. Just based off of the idea. Okay, let me think through this. Do both of those look like a fairly positive pattern?
Yeah.
Could there be a line that goes through both of them that represents it pretty well?
Sure.
So this one is what as opposed to this one? So this one is weaker than this one. So that's what that means. We'll just have things to actually measure it based off of. It's going to be based off of a value of R. And I know I keep talking about these things that we haven't talked about yet, but I'll come back to them. An R value can only go from -1 to +1. Yeah. If slope and R have the same sign, what do you think is going to happen if I get closer to an R of 1?
It's stronger positive.
Stronger positive. So that means my dots that were like this are going to do what? So it would be like something more like that. What do you think it's going to be if it's -1?
Stronger but negative stuff.
Strong but negative. So what do you think is going to happen at 0?
It's just better.
Can you tell me what kind of linear pattern that is? That's what 0 means. Like, I don't see anything there. So in general, that's what this -1 to 1 represents. So anything close to 0 is weak, but we can go to either end to be strong. Now, this is a textbook to textbook thing as far as like a cutoff number. Some of them use -0.75. But our textbook uses these as cutoffs. So anything here is strong. Anything between -0.5 and 0.5 is weak. Anything in between 0.5 and 0.8 on either end is moderate. And you could have written that, I could have written that instead as absolute value of 0.5, less than 0.5 is weak. Absolute value of between 0.5 and 0.8 is moderate. Absolute value of between 0.8 and 1 is strong. But you kind of get the idea of kind of from a graph what that would be. Just an absolute guess, points per game and yards per game, the relationship there, do you think that's going to be, and this is like I said a guess, weak, moderate, or strong? Is it going to be absolutely nothing? So it's probably not weak. Maybe we don't know well enough to know if it's moderate or strong, but there's probably a pretty good relationship there. So kind of a guess at this point. So let's look back at our example. Let's go ahead and label our graph first. So this is going to be our scatter plot. So I'm just writing scatter plot of response versus explanatory for population. What label is going to be on my x-axis? So your x is always your explanatory variable. That should be really easy to remember. So this one for this context is going to be what? Yards per game. And then over here is going to be points per game. And now I want to figure out, let's go ahead and figure out together how we should number this. 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. I have the same numbers as you guys. Okay, so we need to figure out how much we have to cover. So for our yards per game, what numbers am I going to use to figure out what's going to go here and here? Or what I have to cover? Want to find the highest and lowest. So let's look real quick. We've got, what's our lowest yards per game? 276. What's our highest?
605.
So we definitely have to cover those. And I've got this many blanks for it. I have this written down. You might have to help me here because what I have in front of me is 2, 4, 6. Is not numbered the same way as yours. So we definitely have to go below 276. We definitely have to go above 605. And we want to do something that kind of is easy-ish, but we want to cover enough. I want to think through, so you're thinking this if you have one in front of you. How many?
The lowest amount of actual tiles we can use is like when you do the range and then divide it by the 12 spaces, it's 27.4.
So he said, here's our low, here's our high. We covered like this. Did you use this one?
I cannot see.
I know, I'm going to erase it.
I'll use 12 until are we using 11?
But like you start plus 12.
I just divided.
You divided by
range
12.
by 12.
So there's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we need to go there. So he's saying, and don't write what I'm writing. If this number were 276, if this number were 605, I'm doing this and doing it 12 times, right? So if I took the difference and divided that by 12, you end up giving me what?
27.416.
So 27.41 something. Now, do we really want to deal with that number? So let's make it a little bit easier on ourselves. And let's do with like, maybe starting at, we have to start at least here or lower. So what would be an easy number to start at? And it doesn't matter, we can pick. Okay, I'll start at 270 and then let's just go by what instead? 30s would make more sense. So let's go with starting at 270. And does everybody kind of, there's not like an exact way we did this, but I want to help you with like thinking through how you can do it yourself. So here's 270, makes us 300, 330. And so that way I've covered everything I need to, but I'm not just using like a tiny little fraction of the graph. Does that make sense? If we were doing this on our own, there's not like, this is the only right answer. But since we're all going to do this together, I want ours all to look the same. All right, so we're going to do the same kind of deal with points per game. What is our lowest? 13.6. And our highest?
48.
And then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. I have 12 again. So subtracting those, dividing by 12 gives us what?
2.6.
Alright, so maybe we can just go 3 again. So what would be a good one to start with?
10.
I want to make sure I cover everything, and I'm afraid I won't if I don't do that. I might though. So
Why wouldn't you cover everything?
you might, but if it's that close to 3, like I might not hit 48 until I get here.
48.
I mean 3.
Like if I started it, so it was 2 point something.
Yeah.
So it's easy to go by
I
3s,
could go by
and I'm afraid I won't have enough room. So let's just do 12 by 3s. And like I said, if you were doing this on your own, there's no right or wrong answer. Let's skip something. Are you getting the same numbers as me?
That's right.
So like if I would have started at 10, I wouldn't have hit 48 before.
Yeah, I was gonna say go 10 and go by 5s. But
Which would have been fine if you're doing it on your own, but then you've got to, it's harder for you to be able to tell the difference between them. Alright, I actually want, like, we have the time to do this a little bit. I don't want you to spend 30 minutes making the scatter plot, but I want to go ahead and graph this so we have it in front of us to be able to talk about. Now, I will give you a hint as far as if you want to do it this way. Nah, that shouldn't help you here. Alright, so go ahead and I'll split the video here and go ahead and actually graph on your paper. Now, if you have dots that look like this and you can't tell the difference between them, that's not very helpful. If you have dots that look like this, that's also not very helpful. So, I know that people in video can't, but like I did kind of tiny little bubbles so that you can actually see them, but they're not like taking up the whole page. I would probably go somewhere around there. So go ahead and graph these numbers.